Now, what if we have a function which is in the form y is equal to x to the 4 plus x to the 5? What am I going to do here? I know that if I had a function x to the power of n, what I could do was to bring down the power and reduce the power by 1, but that was just for one of them. Here I have two such functions. What do I do then? So that brings us to another differentiation rule. So we basically say, whenever you have two functions, let's say you have fx and gx. So these are your two functions and you want to differentiate them. So two functions, whenever you have two functions that are being added together and you want to differentiate them, basically their differentiation of them is to differentiate each one of them separately. Okay, so remember this only applies if you have an addition or subtraction, doesn't matter. So writing my formula again, I have y is equal to x squared plus x to the 5. That's my function. Now you can see that this function comprises of two individual functions. This is like our fx, we can call it, and this one is our gx. So these two are being added together and we want to differentiate that. Therefore, according to this formula, we can just differentiate each one of these individually. So to do that, what do? We just use this formula for each one of these individually. So for this one, we just bring down the power, reduce the power by 1, and then the same for that, plus the same thing here. So you bring down the power and you reduce the power by 1. So now, based on these formulas that we've seen so far, what we want to do is we want to just look at some miscellaneous examples. So example 1. If I have a function, let's say y is equal to 10x. How do I differentiate that again? Again, this is in the format of a straight line. Therefore, the derivative of this is just coefficient of x, which is 10. What you need to remember is that you can actually solve this using this formula as well. So you say, okay, that's actually to the power of 1. So I can say, I had a formula if y is equal to x to the power of n, what I can do is I can differentiate that using y dash is equal to nkx to n minus 1. And so looking here, you can see that this is basically in the same format as that. Okay, this is another way of looking at it. It's in the same format as that. Therefore, I write it down as 10, which is my coefficient, times the power, which is 1, times this x. Now you need to reduce the power by 1. So it was 1, then you need to reduce it by 1. So what that becomes is just 10x to 0. And remember that anything to the power of 0 is just 1. Therefore, that's just 10. There's no difference between these two methods. You can do it either way. Okay, let's look at another example, example 2. So here, let's say we have a function. Fx is equal to x to the 5 minus x to the 3 plus 6. And what we're trying to do here is we're trying to differentiate this function and basically find f dash x. So remember here, and have a look at here. So here what you have is you have three different functions being added together. So the first two functions are in this format. The last function is a constant. Okay. So we'll do these two first. So this is in the format x to the n, therefore I just use this formula. So I bring down the power, I reduce the power by 1, then the next one. Subtract the 3 because there's a negative between them and you just conserve that. So you bring down the power, you reduce the power by 1. Now we get to the constant. Remember that whenever you had y is equal to k or a constant, then your y dash was 0. Therefore here you will just have 0. And so if I want to write this again, it would just be 5x to the 4 minus 3x squared. Okay, perfect. Another example. So example 3. Let's say I have fx is 3x to the 5 minus 7x squared minus 2. Okay? What I want to do is I want to evaluate f dash minus 1. Okay, so this question is asking me, find out what the gradient is at point x is equal to minus 1. So to do that, the first thing I need to do is I need to find the general derivative formula of this. So let's do that now. We need to find out what f dash of x is first. So this is in the same format as this general formula. I might just draw a line around that formula. So that's one, that's another one, that's another one. Okay, so again, this whole function comprises of 3 different components, each of them being a different function. So the first function is in this format, therefore I just follow the same rule. So you just write down the coefficient, you multiply it by the power, so you bring down the power, you reduce the power by 1, then you multiply the coefficient by the power, and then you reduce the power by 1, and then this one is just a constant, so it just becomes 0. So your f dash of x, or the general formula and the general derivative function for this, is just 15x to the 4 minus 14x. Okay, so now this is generally how your gradient is basically based on whatever value of x you have. This is how you can generally find your gradient at each value of x. But what we want to do is we want to find it at a particular point. So we want to find out what our gradient is at point 1. So all we need to do is we need to substitute 1 in this formula. So it becomes 15 times 1 to the power of 4 minus 14 times 1, which is just basically 15 minus 14, which is equal to 1.